guys, and welcome to Learn Extra Maths Literacy Session 3. In this session, we continue our work with ratio, rate and proportion, but we specifically look at applications of ratios, rates and proportions. Now, ratios are really used in everyday occurrences, so you might find that you will use a ratio when dealing with financial issues, or even if you were trying to convert a baking recipe, or we would use ratio in voting. And this will come up again when we deal with probability. So really, ratio is something that you come across every day, but you might not really recognize that it is a ratio. Recall from the last session that when we looked at ratios, that when you simplify a ratio, simplify means that you're sort of condensing it and making it smaller to work with and easier to work with, or you can sort of expand a ratio by multiplying the ratio by the same numbers. This will then result in an equivalent ratio. So for example, the ratio 1:2 is exactly the same as 25:50. And here what we've done is we've actually expanded this ratio by multiplying both of these numbers by the same factor. So the 1 I've times by 25 and the 2 I've times by 25, so I've times by the same factor. Therefore, these ratios are now equivalent. So we're going to look at a specific case where we make use of ratios. So specifically, we're going to look at baking and how we can use ratios to help us expand a recipe. Okay, so this is example 1, and this is in the context of baking. We're using all of our knowledge on ratios to help us to modify or improve a recipe as we need it. So you are given the ingredients for bread and butter pudding. Now this is just a pudding, as it says, a bread and butter pudding. And what they do is they list the ingredients. So in other words, all the contents, all the things you're going to be using to make this pudding. They tell us you will require 6 slices of bread, 150 grams of raisins, note your units here, 2 eggs, 600 milliliters of milk, again note that this is in milliliters, and 10 grams of butter. They tell you that if you use this combination of ingredients, you will then have enough of this bread and butter pudding for 4 people. Okay, so that's important. This entire recipe is based and will be used for 4 people. So if I'm preparing this for 4 people, I would need 6 slices of bread. So 6 slices of bread for 4 people. 150 grams of raisins for 4 people. So this, you will see what we're doing is we're actually creating ratios here. We're saying 6 slices of bread is to 4 people. Okay, and this we will use again when we actually look at the question. The question says work out, so in other words, calculate the amounts of each ingredient. Notice they said each ingredient, so read your question carefully. They want us to work out every single ingredient here. So that means bread, raisins, eggs, milk, butter. We've got to do it for all of them. Work out the entire amounts of each ingredient needed so that this recipe will be enough for 10 people. So guys, look at what's happened. This recipe that they gave us was enough for 4 people, but now we want to expand it. So we want to go from 4 people to 10 people. We want to feed 10 people with this recipe. So therefore, what do we need? We need to work out how these ingredients need to change. Now, what you should realize is obviously as the number of people increase, as you make this recipe for more and more people, you are going to need more and more ingredients. So as the number of people increases, the number of ingredients are also going to have to increase. Okay, so they ask us to work out the amounts of each ingredient for 10 people. So let's get started on that. We know that 6 slices of bread. Okay, so this is the first part of the question. When we had 6 slices of bread, we then had enough bread in this recipe for 4 people. So I've set it up as a ratio. I'm saying 6 slices of bread is to 4 people. So for 4 people, I will need 6 slices of bread. We want to know how many slices of bread am I going to need if I now have 10 people that I have to bake this pudding for. So you have to say, well, what factor have I used to go from 4 to 10? And because I know as the number of people increases, the number of ingredients or the amounts of ingredients are going to increase as well, I need to times my slices of bread by the same factor. So what factor do I need to times by to get from 4 to 10? I would then have to times the 6 by the same factor. So in order to go from 4 to 10, you would have to times by 2,5, because 4 times 2,5 is 10. Remember though, we can simplify or multiply ratios and keep them equivalent if we multiply both numbers by the same factor. So what I need to do is, since I've times this 4 by 2,5, I need to do the same thing to the 6. I need to say 6 times 2,5, and this will tell me how many slices of bread I need. So if you go 6 times 2,5, you will get 15 slices of bread. Okay, so just repeating that, since I had to times 4 by 2,5 to get to 10, I needed to times 6 by the exact same factor, and that will tell me how many slices of bread I need. So I need 15 slices of bread for 10 people. Okay, that was the bread. The next thing they gave us was the raisins. They said we needed 150 grams of raisins if we were going to make this recipe for 4 people. So again, I've set it up as a ratio. I've said, well, 150 grams is to 4 people. Exactly the way we treated the bread, we're going to do the same thing with the raisins. I need to go from 4 to 10 people. So what do we times by? It's the same factor throughout. To get from 4 to 10, I had to times by 2,5. How we get this factor here, in case you're wondering or if you're not sure about your multiplication, I got this 2,5 by saying 10 divided by 4. That gives me an answer of 2,5, and that tells me what I've got to times 4 by to get to the 10. All right, so the same factor here. To get from 4 to 10, I multiply by 2,5. So I must do the same thing to 150 grams of raisins. I'm also going to times by 2,5 to work out how many grams of raisins I'm going to need. So for the raisins, it's 150 grams times 2,5. And you can do this bit on your calculator. I've already calculated the answer out, and I will get 375 grams of raisins for, again, 10 people. The next ingredient on the list was eggs. And they said to you that you needed 2 eggs if you were going to make this recipe for 4 people. Exactly the same procedure. Now I'm looking at 10 people and I want to know how many eggs I'm going to need. So to get from 4 to 10, all we have to do is times by 2,5. So we're going to do exactly the same thing here to work out how many eggs we need. So 2 times 2,5 will give me 5 eggs. Okay guys, so we're halfway there. We've worked out that we need 5 eggs, 375 grams of raisins, and 15 slices of bread. So the only things that are left really is just the milk and the butter. And once we've worked out how much of milk we need and how much of butter we need, we are done with this part of the question. Okay, they told us that we are looking at 600 milliliters of milk, and I'm going to run out of space, so I'm going to do this alongside here. When we looked at milk, we needed 600 milliliters. Remember to keep your units the same. So you notice when I answered my questions, when we looked at raisins, I answered in grams. So make sure to keep your units the same. So just keep that in the back of your mind. 600 milliliters of milk for 4 people, but I want to get to 10 people, and by now you've got the pattern. The only thing you're going to have to do is times by 2,5, and that will tell you how much of milk you would need. So 600 times 2,5 is equal to, as I said, I've already calculated all of these, but we can do it on our calculator just to show you how we work it out. So we've got 600 times 2,5. That gives me 1,500 milliliters of milk. So that's 1,500 milliliters of milk that you will need. And then lastly, we had to look at the butter. So for 4 people, we needed 10 grams of butter. The same procedure, it's probably becoming boring to you now, but it's exactly the same procedure. We had to times by 2,5 to get from 4 to 10. So I must times the grams of butter by the same factor to keep my ratio equivalent, and I will get 10 grams times 2,5, which is equal to 25 grams of butter. So let's go through all the ingredients that we will need to make this recipe for 10 people. So when you answer the question, we're basically going to just write down the amount of all the ingredients that you will need for 10 people. We are going to need 15 slices of bread. You would obviously have to show all of your working. 15 slices of bread. We needed 375 grams of raisins, 5 eggs, and 25 grams of butter to help us to now use this recipe and expand it and make enough to feed 10 people. So guys, what you've just seen is that we can make use of ratios to help us to modify a recipe and to help us with baking, which is quite useful. Now, the next part of the question, still dealing with ingredients and baking, they ask us to convert. Remember that convert means that we need to convert or change 150 grams, so that's a measurement unit, to ounces, which is also a measurement unit. And they give you the conversion. They say 450 grams is equal to 1 pound. That symbol LB, that stands for pound. So 450 grams is equal to 1 pound. Here, guys, don't get confused with pounds. When you remember when we dealt with exchange rates, we also spoke about pounds. That was a different kind of pound. That was money, currency. Here we're talking about measurements and weight. So the pound we are talking here about helps us to weigh stuff. This is not the same as the pound that we used in exchange rates. And they also tell us that 16 OZ, or 16 ounces, that's the abbreviation for ounces, is equal to 1 pound. They then very specifically say, give your answer to the nearest ounce. So you need to be careful of how you round off there. Okay, so let's get all of this down. We've got 450 grams. We're told that 450 grams is equal to 1 pound, and 16 ounces is equal to 1 pound. You are asked to convert or change 150 grams, and the unit that they want you to end up with is ounces. Okay, so you're going from grams to ounces. Now, there's more than one way to do it. I think probably the easiest way to do it is to notice that both of these 450 grams and 16 ounces, they're both equal to 1 pound. So if 450 grams is equal to 1 pound and 16 ounces is equal to 1 pound, that must obviously mean that these two are equal. Okay, think about that for a second. If they're equal to the same thing, they must be equal to each other. Okay, so therefore we can go straight, if you understand that concept, and say, well, since they're both equal to 1 pound, we basically can create a conversion between grams and ounces. So that means that 450 grams would equal to 16 ounces because they are both equal to 1 pound. Okay, so if that's equal to that, that's equal to that, they must be equal to each other. All right, so if 450 grams is equal to 16 ounces, and we want to convert 150 grams to ounces, again, let's set this up as an equation. This is my preferred method of working with exchange rates and any type of conversion rates, or any type of conversion, is to set it up as an equation. 450 grams is equal to 16 ounces. But we don't want to convert 150 grams. No, we don't want to convert 450 grams. We want to convert 150 grams. Okay, so there's a difference here. All right, what is that difference? In order to get from 450 to 150, what do you have to do? You have to, and hopefully you all said it, you have to divide by 3. Because 450 divided by 3 will give you 150. Okay, but because this is an equation, to balance it out, if I'm going to divide the left-hand side by 3, I'm going to have to do exactly the same thing to the right-hand side. So 450 divided by 3 gave me 150. And then if you say 16 divided by 3, what do we get? Okay, we can't leave it like this, remember guys, because they said they wanted to the nearest ounce. So we're going to have to use our calculator here just to help us with the fractional bit. We want to know what 16 divided by 3 is. And the answer is 5,3 recurring. But because they said to the nearest ounce, we just have to round it up to 5. Okay, so this is just going to be 5 ounces. So 150 grams is exactly the same as 5 ounces. Okay, so if you understand that concept, that is actually the easiest way to do that question. The easiest way, since they both are equal to 1 pound, equate them to each other and then change from grams to ounces straight away. Another way for you to do it, if you're not too comfortable with that method, is we can first go from, because remember they gave it to you, grams to pounds. So we can first go from grams to pounds, and then from pounds to ounces. You will get exactly the same answer. So you can first convert your grams to pounds, and then from pounds to ounces. So I'm going to write that method down, but we're not going to work it out because you will end up with exactly the same answer. So the other way to do it is first convert from grams to pounds, or let me write this in words so that you don't get too confused there. So the one way to do it was the way I've already shown you, or we can go from grams to pounds and then go from pounds to ounces. So that's another method of doing it. So take your 150 grams, see how many pounds that will give you, then take that number of pounds and convert that to a certain amount of ounces. You will still end up with, at the end of that, 5 ounces. Okay, and guys, so that's how you really are going to make use of ratios to help you to simplify and modify baking recipes. But as I said to you, ratios and proportion come up in so many different sections, and you can also make use of ratios in financial sections, as you will see later on, and in probability. So guys, we're now going to look at example 2, which is an example again using ratio, but in this case we are going to use ratio to help us to work out population numbers. Specifically, we are going to look at crude birth rates. Now that sounds really confusing, but all that a crude birth rate is it's the number of babies for every 1,000 people per year. So it really is just a rate. It's telling you the rate at which the babies are being born per 1,000 people. The question says, in 2004, South Africa's crude birth rate was 18,2 births per 1,000 of the population. So straight away, because they have given us the crude birth rate per 1,000 of the population, we can already set that up as a ratio and say we've got 18,2 births per or for every 1,000 of the population. They then say if the population at that time being 2004, was 44 million, approximately here is a clue to you that you're probably going to have to round off. Approximately how many babies were born in that year? So how many babies were born in 2004 when they give you the crude birth rate and they tell you that your population was 44 million. Now guys, remember when we deal with 44 million, we need to write that down as a number. And remember that a million implies we are dealing with 6 zeros. Okay, so to write that down as a number, it would be 44 and then 1, 2, 3, 4, 5, 6 zeros. Okay, first let's deal with our ratio, because remember we're aiming to find out how many babies were born, but we just have that the crude birth rate was 18,2 births per 1,000. So we can simplify that a little bit. And remember that in a ratio, if you divide both numbers by the same factor, we do not change the ratio. So therefore, if I divide the right-hand side of this ratio by 1,000 to get it to 1, and if I do the same thing to the left-hand side, these two are in fact equivalent. Okay, so all I've done here is I've just written it in a bit of a simpler form. I've said for one person, this would be the number of births, 18,2 over 1,000, and I'm going to leave this in that form, in fractional form. If you want to, you can in fact write that as a decimal. Okay, now remember we were dealing with not one person here. In 2004 there was 44 million people. So in order to get from one person to 44 million people, what do we have to do? Hopefully you all answered. You had to times by 44 million. So we times 1 by 44 million to get to 44 million people. But because this is a ratio and I want to keep it equivalent, I need to multiply the left-hand side by 44 million as well. Okay, so let's go over that again. We've got our crude birth rate. We want to work out what the number of births is for 44 million people. So all we did was we simplified our ratio, got it down to that's the number of births per one person. And I'm going to then times by 44 million to get it in numerical terms to work out how many babies are being born. So we call up the calculator and we're going to type in, you can use brackets here, 18,2 divided by 1,000, close our brackets, times 44 million. Remember we've got 6 zeros, so it's 1, 2, 3, 4, 5, 6, and that gives us 800,800. Therefore, we've got 800,800 births per 44 million of the population. So in this way, we have actually used ratios to help us to get all the way from a crude birth rate of 18,2 per 1,000 people to an actual answer. So we can work out that if we had 44 million in 2004, if we had 44 million people, then there were 800,800 births in that population in 2004. So guys, that's the last example that we will be looking at using ratio. But you will be required to use ratios again in the exercises at the end of this section. In the meantime, let's move on to proportion. Now, there are really two types of proportion that we are going to be dealing with here. We are going to look at direct proportion and indirect or inverse proportion. So firstly, let's just look at direct proportion. Now, a direct proportion is really if one quantity is directly proportional to another quantity. So if a quantity A is directly proportional to another quantity B, what this really means is that if A increases, then B would increase by the same factor. And what that would ultimately mean is that the ratio of A is to B will be unchanged in a direct proportion situation. So your ratio is constant. So a really good example is speed versus distance. We know that speed is directly proportional to distance, and the reason for that is if you double your speed, so let's call speed S and we call distance D. So if you double your speed, in other words, times it by 2, then you will double your distance. So the ratio of speed is to distance will remain unaffected. Okay, so speed is directly proportional to distance, and hopefully your marks are directly proportional to the amount of hours you spend studying. So hopefully the more you study, the better your marks will be. Okay, we're going to move on to indirect proportion or inverse proportion. And here what we really mean is if a quantity A is inversely proportional to another quantity B, then inverse means that as A increases, B would decrease. See, that's very, very important. If A is increasing, B would be then decreasing by the same factor. Okay, again, we're going to use the example of speed, but this time what you should know is that speed is inversely proportional to time. Now, what we mean by that is, well, if you just think about it, the faster you go, the less time it's going to take to get to your destination. But how this works with proportion is that if you were to double your speed, okay, so you times your speed by 2, you increase it by a factor of 2, then you will halve the time, or times by a half, divide by 2. You will divide the time by 2 that it takes to travel the same distance. The important thing with inverse proportion is you will always have something that's constant. And in this case, when we're looking at speed versus time, the thing that's constant is the distance. So if you're traveling the same distance and you double your speed, so it's 2 times the speed, then your time you will have to divide by 2 or times by a half. All right, so I hope that all makes sense to you guys. Speed is inversely proportional to time. So as you increase one, you have to decrease the other one by the same factor. So for example, since I times speed by 2, I need to divide my time by 2. All right. So guys, example 3 is an example using inverse proportion. So bearing in mind that speed is inversely proportional to time, let's look at example 3. Here we are told that an airplane completes a trip from Joburg to London. Okay, so your journey goes from Joburg to London and it's in 10 hours. So therefore your time taken is 10 hours. They then say if a new type of faster plane can travel on average 1,2 times faster than the old plane, how many hours will the same trip take on the new plane? Okay, so there's a few key things to note here. They've given us the total time. They've said it takes 10 hours to get from Joburg to London. And they then tell you that you're using a new type of faster plane that can go 1,2 times faster than the old plane. And straight away, it should, you should stop and think, obviously, if I'm going to be accelerating more or going faster, then the quicker or the less time I'm going to use on the same journey. So when they ask you how many hours will the same trip take, really what you're keeping in mind here is that speed is inversely proportional to time. Okay, again, the faster you go, the quicker you're going to get there. All right, so they gave us that the time is 10 hours for the trip. They have told you that your new plane can travel 1,2 times faster. So it's 1,2 times faster. So that means your speed is 1,2 times faster. And since speed and time are inversely proportional, this should straight away tell you that my journey is going to be 1,2 times quicker. So it's going to be 1,2 times quicker to get to the same place. All right, so because they're inversely proportional, if I times my speed by 1,2, what do I have to do? I have to divide my time by 1,2. So I take, it's the same journey, we're going a little bit fast, or we've got a faster plane, so our 10 hours divided by 1,2 will tell us how quick we are going to get there, or how much quicker this journey is going to take us. All right, so we've got 10 divided by 1,2 on our calculator, and that gives us an answer of 8,33 hours. So it's 8,33 hours that it will take. So the same journey from Joburg to London will now take 8,33 hours if we now have a plane that's going 1,2 times faster. So this concept of inverse proportion is really important. So we're going to do another example using inverse proportion. Guys, now this example on inverse proportion is a little bit trickier than the other ones that we have dealt with. So let's go through it carefully. They tell us that a team of 2 workers, so this team has 2 workers in it, they take a day to put up 10 squared meters of roofing on average, and a house has 440 squared meters of roofing. They want to know how many 2-worker teams, so how many teams will be needed to put up the roof in 4 days. So they've given you a specific time period. We want to complete this job in 4 days. They told us that we have to put up 440 meters squared of roofing, and they want to find out how many teams. So how many people how many teams of 2 people are we going to require? So first, let's just realize that the team of workers is inversely proportional to the time it's going to take to put up this roofing. Because obviously, the more workers you have, the quicker this job is going to get done. So if I have, with the 10 meters squared, when we're talking about that amount of roofing, if I have 1 team, I know that's going to take me 1 day. But remember, your team and your days, these are inversely proportional. So if you were to have, say, for example, 2 teams, then to work out the number of days it would take, what would we do? Since we times by 2 here, because it's going to take me quicker now, I'd have to divide by 2 on this side. So it would take half a day to put up 10 meters square of roofing if I have 2 teams. If I had 3 teams, just to show you the pattern here, so What would I do then? I went from 1 team to 3 teams. That means I times by 3 on the left-hand side of this. So I would have to divide my number of days by 3. And this would take me a third of a day to put up 10 meters squared of roofing. Okay, so that's really the concept of what's going on here. But we are not dealing with 10 meters squared. We are dealing with 440 meters squared of roofing. All right, so we know that we know that 1 day, it takes 1 day to put up 10 squared meters of roofing. So we want to find out, well, how many days is 440 squared meters going to take? Now, there's really 2 parts to this question. Remember, ultimately, we want to find out how many teams are we going to need if we want to do this job in 4 days. But in order to get there, we've got to break it up. So firstly, what we're doing in this part of the question, in this part of this answering this question, is we're looking at the direct proportion. We know that 1 day will take 10 squared meters. So the more, as I'm going to increase the amount of roofing, I'm going to obviously increase the time it takes to put up that roofing. So if 1 day for 10 meters squared, I can write this as a ratio. 10 meters squared is to 1 day. And I want to go to 440 squared meters. I want to find out, well, how many days is that going to take on average? How many days is 440 squared meters of roofing going to take? So to get from 10 to 440, we have to times by 44. And because our roofing is directly proportional to the number of days, I would have to multiply my days by 44 as well. So therefore, it will take me 44 days, or it will take the teams 44 days. It will take 1 team 44 days to put up 440 meters squared of roofing. Okay, so that's just dealing with 1 team. 1 team would take 44 days to do this job. All right, but we want to know now, how many teams am I going to need if I want this job done in 4 days? All right, and now this is the inversely proportional part, because the more teams we have, obviously, the quicker the job is going to get done. So as my number of teams go up, the number of days is going to go down by the same factor. So we have 1 is to 44 days, for 1 team for 44 days. But I want to get this job done in 4 days, and I need to know how many teams this is going to require. So, to get from 44 days to 4 days, what did you have to do? We had to divide by 11. So, on this side, because these are inversely proportional, be very careful. I'm not going to divide this by 11. That will give me the wrong answer. Because these teams and the number of days are inversely proportional, if I divide 44 by 11 to get to 4, I need to times the number of teams by 11. So 1 times 11 will give me 11 is to 4. So therefore 11 teams will complete this job in 4 days. Okay, so let's just go back and recap a little bit, because this is a bit of a complicated example. The first thing we did here was we saw that if we were just working with 1 team, this job would have taken us 44 days. Okay, so this job, to put up this 440 meters squared, would take us 44 days. But we want this job done in 4 days, and that's where the inverse proportion of this question comes in. If I want the job done in 4 days, I had to divide my number of days by 11 to get to 4. And because the teams and the number of days are inversely proportional, I had to times the number of teams by 11. So in actual fact, it will eventually take 11 teams 4 days to put up 440 meters squared of roofing. So we have in fact answered the question in full. How many worker teams? 2 worker teams. It would be 11 2 worker teams. Before we move on to the section on rates again, we need to do a quick recap of formulae and how and when we use formulae. Remember that a formula is used to calculate any unknown quantity, where variables are used in place of the numbers. Now, all that a variable is it's a number. It's sort of like a placeholder for a number. So you can basically substitute numbers wherever the variables are. So in some cases, you might have x's in your formula or whatever the case is, but the variable is just really a placeholder for a number when you're looking at a formula. So some of the formulae that we will use will be used in this example, example 5, where we are going to try and convert between Fahrenheit and Celsius. And this is just a typical formula type of example, and most of your work here, besides your actual substitution, is going to be done on a calculator. So you are told that the formulae for converting temperatures between degrees Fahrenheit, which is not generally the used or acceptable method of temperature reading in South Africa. So what we're doing is we're converting from degrees Fahrenheit and degrees Celsius, which is what we use in South Africa. And they give us those formulae. They say C, which is the one that gives us our conversion from Fahrenheit to Celsius. They give us our degrees Celsius conversion, and they give us the Fahrenheit conversion. And this is the formulae that they give us to convert from one to the other. So the F in this case would be the variable. That is the thing that's going to change. A variable changes as you go from one problem to the next. It's never ever the same. It continually changes, hence the word variable. So depending on what the degrees Fahrenheit is, the degrees Celsius is going to change according to that change in Fahrenheit. And similarly on this side, your C is your variable, and as your degrees Celsius changes, your degrees Fahrenheit is also going to change. They then tell you to use these formulae to answer the following questions, and they give you a whole lot of conversion questions. Now, as I said to you here, you need to know how to use your calculator. So calculator skills, very, very important. Okay. They firstly tell you that you need to find the boiling point of water, so the temperature at which water begins to boil, in degrees Fahrenheit, if the boiling point of water in degrees Celsius is 100 degrees Celsius. So they gave you something in degrees Celsius. They're asking you to convert it into Fahrenheit. So that means the formulae that you're going to use, or the formula you're going to use, is this one. The one that converts your Celsius, your degrees Celsius, to your degrees Fahrenheit. All right, so you will get a mark for substitution. So you would need to show your substitution. So we've got degrees Fahrenheit is equal to 9/5 times our temperature in degrees Celsius, which is 100 in this case, plus 32. So all I want to do really, I want to substitute the degrees Celsius in, and this is going to give me my answer for degrees Fahrenheit using the formula that they gave you. That's just a really, really simple question, and we're going to be doing this all on our calculator. So we call our calculator up, and we're literally just going to type in these numbers. So it's 9/5 times 100 plus 32. So that gives me 212. So therefore, The boiling point of water in degrees Fahrenheit is 212 degrees Fahrenheit. And that's the symbols that we use, degrees and then the F, or the degrees and the C if we're working with Celsius. All right, so the boiling point of water, now you know, is 212 degrees Fahrenheit. Now question 2, it's all just a whole lot of conversion questions. And here they gave us, we're either going to have to go from degrees Fahrenheit to degrees Celsius or degrees Celsius to degrees Fahrenheit using the very same formulae that they gave us in the beginning. So the first one, A, gives us 75 degrees Fahrenheit. So that means we need to get to degrees Celsius. Not sure what happened there.
It's fine, you can continue, I'll clean it.
Okay, so we're going to convert from 75 degrees Fahrenheit to degrees Celsius. So the formula we're going to use is the one that will convert from Fahrenheit to degrees Celsius. And it's C is equal to 5/9 times F minus 32. That was the one that they gave you at the beginning. So in degrees Celsius, it's going to be 5/9 times 75 minus 32. You can then put this into your calculator or work this little bracket out first and give your answer and then put it into the calculator. But ultimately, let's see what we get. So we're going to have 5/9, open up, sorry, let's just do that again. So we're going to have 5/9. We want our brackets there, so we're going to have 75 minus 32, close the bracket, and that will give me 23,888 and so on. Now, they haven't really said how we should round off, and remember, we have told you this many times before, if they don't tell you, then round off generally to 2 decimal places. So in this case, I'm going to round this off to 2 decimal places. So this would be 23,89. So it's 23,89 degrees Celsius. Okay, the next one again, we're going from Fahrenheit to degrees Celsius. So we're using the same formula. So that was A. Let's look at B. So we're just basically substituting into our formula. We know this time the value of F, and this is what I was saying, F is variable, so it's going to continually change. This time we're looking at 100 degrees Fahrenheit. We can put all of this into our calculator. All right, so it's 5/9 times 100 minus 32. And this gives me an answer of 37,77. Again, using the principle of rounding off to 2 decimal places, this would be 37,78. So that's 37,78 degrees Celsius. All right, because we needed to go from Fahrenheit to Celsius, so we end in degrees Celsius. Okay. Then number B, they want the number C, they want the opposite. They want you now to go from degrees Celsius to degrees Fahrenheit. So here, you've got to use the right formula. And the formula that they gave you that converts from degrees Celsius to Fahrenheit is that one there. So that's the one we're going to put in. Again, guys, you will get marks for showing your formula substitution. So please show that work. Okay, and we know in this case we're looking at C, we're going from 0 degrees Celsius. So we're going to have 9/5 times our degrees Celsius is 0 plus 32. You don't really need a calculator for this one because 9/5 times 0 is 0. 0 plus 32 is just 32. So therefore 0 degrees Celsius is the same as 32 degrees Fahrenheit. Okay, and then the last one here where we're using our formula to convert, we've got to change -5 degrees Celsius, so a really cold temperature. We want to see what is that going to be in Fahrenheit. So again, exactly the same thing. We're going to use this formula that converts from Celsius to Fahrenheit. It's 9/5 times -5 plus 32. Okay, this you can put into your calculator, but again, it is an easy one. You could just cancel off your 5s and you will get -9 here. So just simplify that a little bit. Plus 32. And 32 minus 9, if you do need a calculator for that and you can't do it in your head, then you can do that in your calculator and you get 23 degrees Fahrenheit. So this would be 23 degrees Fahrenheit. So example 5 was really just a way that you could help or you could use formulae to help you to solve for unknown values. Now there are various cases where formulae are used and we will come across these in the exercises as well. But really just using a formula helps you to simplify the matter and helps you to find unknown quantities. So we are once again going to look at exchange rates. Now, exchange rates are specifically very important when we deal with the import and export trade. Now remember that exchange rates make it possible for different countries who use different currencies to trade with each other. When a country imports, very important word, imports a good from another country, it's buying the good from the other country. So import is the same as buying. So if South Africa, for example, is importing DVD players, then it is buying DVD players from another country. When a country exports goods to some other country, it's selling goods to the other country. So exporting is the same as selling your goods or your country's goods to another country. So, for example, if South Africa is exporting bananas, then we are selling bananas to another country. Import and export duties, these are really just fees that are charged on imported, so that's goods coming into the country, and exported, goods going out of the country. So that's import and export duties are charged on either imported or exported goods or products. And as I said before, the import and export trade is very reliant on the exchange rate. Now this becomes especially important for exporters and importers. Now if we look at an example of that kind of thing, if I'm talking about the rand being weak against the dollar. So if we, for example, talk about the US dollar, and if the rand is weak against the dollar, then your exporters, remember those are the people who are selling their goods to America in this case, they will get more rands for every dollar that they get paid. That is if the rand is weak against the dollar. Now by contrast, if the rand is strong against the dollar, then what this means is it's actually going to be bad news for the exporters because they will get fewer rands for every dollar that they receive. So for every good that they're going to sell overseas or to America, they are going to get fewer rands if the rand is strong against the dollar. So in other words, if it costs less rands to buy a dollar. Okay, so guys, we're going to look at, it's important to keep all of these concepts in the back of your head while we look at some examples on the exchange rate and how we use it. Okay, so example 6, we have a farmer exports citrus fruit to the United Kingdom. And the client exports, first let's just make a note of that, export means he's selling it to another country. So from his own country, his domestic country, he sells it. He exports citrus fruit to the United Kingdom. The client, whoever's buying his fruit in the UK, has agreed to pay £10 for a box of oranges, okay, £8 for a box of nectarines, £9 for a box of grapefruit, and the farmer exports 500 boxes of oranges 600 boxes of nectarines, and 200 boxes of grapefruit. So they've given you a whole lot of information here, a lot of conclusions that we can make from this. But let's look at what the question asks. They want to know how many pounds does the UK clients have to pay? Now, the UK client, remember, the United Kingdom client, he's the one who's buying. He's buying the fruit from the exporter. And remember, he has agreed that he will pay £10, the symbol for pounds, something like that. He's going to pay £10 for a box of oranges, £8 for a box of nectarines, £9 for a box of grapefruit. So if we want to work out in total how much this UK client is going to have to pay the farmer, all we need to do is we need to times the amount by the number of boxes that he is getting. So for example, if he gets 500 boxes of oranges, then I need to times that by £10 because that's how much each box of oranges costs me. Okay, so we can say the amount that he will get is going to be £10 times 500 boxes of oranges plus he has to pay £8 for each box of nectarine, and we're dealing with 600 boxes, so it's 8 times 600 plus we know that it's £9 for one box of grapefruit, so if I'm looking at 200 boxes, I need to times 9 by 200 to give me the total he's going to pay for all the boxes of grapefruit. Okay, so if we work this out, we can work each of these individually out on our calculator and then put down the final answer. Or we can just put all of this into the calculator and let's see what we get. Okay, so we've got 10 times 500 plus 8 times 600 plus 9 times 200, that's for your grapefruit, close our brackets, and we get 11,600. But 11,600 what? 11,600 pounds. Okay, generally they will give you the symbol that you should use, so you don't have to remember what the symbol is, but that is the symbol for pounds. So therefore the UK client will have to pay 11,600 pounds. How did we get that? We times the price of each box of fruit, and we times that by the number of boxes of fruit that this person was buying. Okay, now the next part of the question tells you what the exchange rate is. They say 11 Rand 95, the exchange rate is 11 Rand 95 to the pound. How many rands will the farmer receive? So obviously, if the UK client is paying that, who is he paying that to? He's obviously paying that to the farmer. So the farmer is going to get that amount, but he is all the way here in South Africa, so he's not going to get this money in pounds, he wants it in rands. So we need to convert this 11,600 pounds into rands. They did tell us that 1 pound is equal to 11 Rand 95. Okay, but we know that he is not getting just 1 pound, he's getting 11,600 pounds. So we can treat this as an equation and say, well, I want to work out how many rands I'll get for 11,600 pounds. So to get from 1 pound to 11,600, we have to times by 11,600. Keeping the equation the same, that means I will have to times the right-hand side by 11,600 as well to work out how many rands he's going to get. Okay, that's something you can put into your calculator. So it's 11,95, that's our exchange rate, times the total amount of pounds, which is 11,600. That will give us 138,620 rand. So it's 138,620 rand. Okay, so let's just understand what's happened here. The UK client is going to have to pay 11,600 pounds. Then after all the processing of exchange rates, we see that the farmer in South Africa is actually going to get the equivalent of that, which is 138,000 rand and 138,620 rand. Okay. They now change the exchange rate up. They say, if the exchange rate was 12.95 to the pound, how much will the farmer receive? So all that's changed here, it's exactly the same question. The only thing that's changed is your exchange rate. So we've got £1 is now equal to 12.95 rand, and before £1 only cost 11.95 rand. So now we've got to pay more rands in order to buy just £1. So straight away that should get your brains thinking, what does it mean when I have to pay more rands to get £1? Well, we're going to see. Okay, they say if the exchange rate was 12.95 rand, how much will the farmer now receive? So he's still going to get 11,600 pounds. That's what the UK client, the person in the United Kingdom, has agreed to. He is paying 11,600 pounds, but because the exchange rate has now changed, and this is what we were saying in the previous ratio and proportion and rate section, the exchange rate changes continually. So because the exchange rate has now changed, we are going to get a different rand amount. So the same thing, to get from £1 to 11,600 pounds, we times by 11,600. We're going to have to do the same thing to our rands to keep this equivalent. So to 12.95 rand, I have to times by 11,600. And we're going to do that on the calculator. So it's 12.95 times 11,600 pounds. And now he gets, okay, let's just do that again. So it's 12.95 times 11,600 with all the zeros. He will get 150,220 rand. So 150,220. So look at that comparatively. The exchange rate has now changed. So now £1 costs 12.95, whereas it used to cost you 11.95. And is that good news or bad news for the farmer? It is excellent news, because now that the rand has weakened against the pound, the exporter, the farmer, the person that's selling his fruit, is getting more money out of it. So therefore, every time the exchange rate actually weakens, this is what I was saying to you at the beginning, this will then become a better situation for exporters. And if you're on the other end of the coin, then it will be a worse situation for an importer. All right. So then the question says, is the rand weaker in question 2 or 3 above? And I've already said this to you, but it is weaker. And the reason for this is because it costs more rands to buy £1. So that means that our currency, the South African rand, has actually weakened against the pound when it costs more rands to buy the same pound from the UK. Okay, guys, now that is really a typical exchange rate exam type question. So make sure you understand all of the concepts there, and also understand how important the exchange rate is to the import and export trade. Okay, everyone, it's now time for you to attempt the exercises by yourself. The following 4 exercises are designed to just test all of the knowledge that you have gained in the section we have just done. So let's look at exercise 1. Here we are asked how many 4 kg packets, important to note here your units. we want to know how many 4 kg packets of sugar will be required to bake 80 cakes, each containing 250 grams of sugar. So you'll notice here that your sugar is given to you as 250 grams of sugar, each cake containing 250 grams, but they want your answer in terms of 4 kg packets. So a big clue for you here is you need to make use of your conversion factor, which is 1,000 grams is equal to 1 kg. That's going to be critical in doing that question. So you're going to have to be able to convert from grams to kgs in order to answer this one. Then exercise 2, they tell you that your exam paper at the end of the year will be 3 hours long. So they've given you the time that you will take to do the exam. They tell you that it's out of 150 marks, so that's your total marks. And the first part wants to know, well, how many minutes? And guys, this is where your units become so important, because they've given the question to you in hours, but, well, they've given the explanation to you in hours, but their question requires your answer to be in minutes. Okay, so you've got to be careful there. Make sure you are aware of your units, because if you do give the wrong units, you will lose points. So the conversion that you will use here, that's quite important, is that 60 minutes is equal to 1 hour. And that's really all you need to help you with that question. And just remember, because it's an equation, what you do to the one side, you have to do to the other side. They then want to know at what rate, so how fast should you work? How many marks should you work towards per minute? How fast should you work to ensure that you finish the exam in the time that is allowed? And my big clue to you here is to set up a ratio. We know that it's 150 marks, which they told us, in the total time, which you would have worked out here in minutes, so keep it in minutes. So this is your total time in minutes. So it's 150 marks in a certain amount of minutes. And all you're going to have to do from there is simplify your ratio. And that will get you to the answer of what rate you should be working at. Something everyone needs to know for the end of the exam. So with exercise 3, it also is a rate question. We are told that Thabo jogs at a rate of 250 meters per minute. So that's the rate at which Thabo is jogging. They want to then know how far in kilometers does he jog in 15 minutes. So we want to know how far in kilometers will he jog in 15 minutes. So there's a bit of information, quite a bit of information that they give you here. Let's write down the one as a ratio, and that would be my big clue to you, is he does 250 meters per minute. Okay, so you want to convert from this to 15 minutes. How far will he go in 15 minutes? That's what we're trying to find out. We want to know how far is he going to go. But they don't just want the answer, they want the answer in kilometers. So something you're going to have to know here is that 1,000 meters is equal to 1 kilometer. Now, usually in an exam situation, if they require you to do a conversion, they will give you the conversion in most cases. So they will say to you 1,000 meters is equal to 1 kilometer. And that will really help you to work out how far he's going to go in 15 minutes. So guys, it's on to the last part of this exercise, which is exercise 4. And this is really a typical exam type question. Okay, it's really taken into account all of the work that you have done on ratio and also the work that you have done on percentages. They say in order to expand your small business, you decide to take on a business partner. Remember, a business partner is just someone that's going to help you to make your business better, we hope. Now, you contribute 45,000. Contribute, that means that's the amount of money you're going to put into the business. And your partner contributes 30,000, this should say 30,000 Rand to the business. The first question asks you to write down the ratio of your contribution to your partner's contribution in simplest form. They say in simplest form, guys, that tells you that when you get your answers, you need to go as far as possible. And my only clue to you here, because this really is self-explanatory, is to write down the ratio of your contribution, which is 45,000 Rand, to your partner's contribution of 30,000 Rand, and just simplify that and see what you get. Now, let's move on to the B part of this. They say that if your income, now remember, income, this is money that you are earning. This is money that's coming into your business. So this is what you are earning. If that income is 20% greater than, so that means more than your income from last month, how much does your business make this month if your income last month was 55,000 Rand? So they give you your original income or your income from the previous month. They want to know, what is your income now? How much are you going to get this month if it's 20% more? All you have to remember here is how to increase by a given percentage. So to increase, to get your new amount, you take your original amount and we times that by 1 plus your percentage over 100. So ideally, we would like this in decimal form. So you take your original amount, times that by 1 plus your percentage over 100, and that will give you your new increased amount. This is really the quickest, most efficient way to increase by a given percentage. And that will help you to work out what your income is this month. Okay, so for the last part of this exercise, we are told that the business makes a profit. Profit is what you are left over with after you've paid all your costs and all of your expenses. So your profit is really your income minus your expenses. And this is something we will get into more detail. With in financial maths. Okay, so your profit is just your income minus your expenses. So it's what you're left over with. And we are told that it makes a profit of 10,000 Rand. And they want to know how much will each of you get if you split the profit in the ratio of 3:2, with you getting the bigger share. So what they're really saying to you is, in this ratio, it's divided in the form of your share and then your partner's share, because you get the bigger part of this share of money. So here, in order to help you, you need to change this to a proportion and say, well, I know that this money is going to be divided into 5 parts. Therefore, if I'm getting the bigger part of this, I must be getting 3/5 of that. So you will find 3/5 of your 10,000 Rand, and that is how much you will get. And you can then also work out how much your business partner will get. So that concludes this section on ratio, rate, and proportion. In this section, we looked at further examples of ratio, further examples of proportion. We also looked at using formulae and further examples on exchange rates. Make sure that you can do all of the exercises that we left you, and good luck.